In this video, we're going to go over how to simplify square roots when there's variables to powers in them. How do we deal? Well, I'm going to show you why it works first. We're going to understand the why, and then I'm going to show you behind that why that there's a very simple process. In a later video, we'll do a whole bunch of practice problems on it. So this is more about the why and the how behind it with simple problems. Okay, so first things first, we have x to the sixth inside the radical. We're saying the square root of x to the sixth. That's like saying what number, when squared, gives you x to the sixth. So we're literally saying x to the what power, we'll put a question mark there, when squared. So we're saying x to the something, we're going to square it, and that's going to give us x to the sixth. So some number when squared gives us x to the sixth. Well, let's think about that. Well, we know that with exponent powers, we multiply the powers. So you'd have x to the 2 times question mark equals x to the sixth. For those to be equal, we would need the exponents to be equal. So 2 times question mark equals 6. How do I solve? Divide by 2, which actually gives you the nice process. So the answer to this is that the power here is 3. So this would be x to the third. All we did there, we divided the exponent by 2. So when you take the square root of a variable raised to a power, all you have to do is divide the exponent by 2. That's the square root action being taken on the exponent. The reason again being, you're saying x to the something squared will give me this. So that ends up being 2 times that exponent. You're undoing 2 times the exponent to get the exponent that we have already by doing division of 2. And it's always division by 2 when you have a square root, because it's always what number squared. All right, so let's see what happens when we have an odd power. Okay, well, with an odd power, if you have the square root of y to the fifth, well, what we have going on here is you have 5 divided by 2, but that doesn't go into it evenly. 2 goes into 5 twice with 1 remaining, and I do a remainder and not a decimal because there's one very important distinction here. What's happening here is you've got the square root of basically y squared times y squared times y. So you have 2 pairs of y squareds. That gives you y to the fourth times y would get you back to y to the fifth. Each of these y squareds, you can take the square root of them. That would be y. This would be y. That would give you y squared on the outside, right? A pair of y squareds. That's the 2, y to the 2. The 1 remaining is y to the first power. So when you have an odd exponent, you still divide by 2. And then when you have a value remaining, that's the power that is remaining inside of the square root. Now, one thing I need to say is that this assumes that x and y are both greater than or equal to 0. Right? In a later math class, you'll see what happens when we don't assume that. So we're not going to work in absolute values quite yet. That'll be in a later video if you're watching this in Algebra 2. It'll be in a later math class if you're watching this in Algebra 1. All right, let's use this technique to see how quick it is. So x to the 30th, we're taking the square root. All we do is divide 30 by 2. And that leaves us with 15. Nice. So the power that we have out is x to the 15th power. It's that simple. We're taking the square root of b to the 17th. 17 divided by 2. 2 goes into 17 8 times with 1 remaining. And so that means that we have b to the 8th power with 1b remaining inside of the radical. It's beautiful. Here's why it works. Here's the process in action. And that's proof that if you understand why, it leads oftentimes to a process that's super simple. But if you just memorize a random process, we don't really understand what that's built on. All right. I'll see you in a later video where we do a little bit more involved problems using this process. See you there.